Morning guys, our lesson today, lesson number 1. We need to redefine the function. Okay, what is the meaning the function or mapping? Already you have studied what is the meaning of function. Okay, the function is a relation from x or set x to a set y. What about the condition of the function? And each element of the set x has been connected with just one and only one element what in the set y. For example, we have set x and set y, and we have elements in the set x a, b and c, and the elements of y, d, e and f. So this function or not, look, we have in the set x a, b and c, and each element has one image in y. So the element a, it's image e, the element b, it's image d, the element c, it's image f. So this function, it's called the function, or this relation, it's called the function. What about this? Element a in the set x has two images in y, so this relation is not a function. And we have another reason. The element c that belong to the set of x has no images in y, so this relation, it's called not a function. And we have many notes. Okay, the set of x, it's called function, the set of y, it's called codomain, and set x, it's called domain. What about the elements in y or the images in y? It's called what? It's called the range of the function. After that, we have an example. If x equals or set x equals 1, 2, 3 and 4, and set y equals 1, 3, 5 and 7, which of the following relations? Okay, we have three relations, R1, R2 and R3. Okay, which of the following relations, okay, represents a function or not? Look to R1. We have many order pairs, 2, 3, 1, 1, 3, 5, 3, 7 and 4, 3. To check your relation is a function or not, okay, you have to search in x elements. We have 2, we have 1, we have 3 and we have 3. So number 3 repeated twice. So this relation is a function? No, because I said the relation to be a function, the element in x must have been connected just one element in y. And R2 and R3, okay, you have to check by yourself. Okay, after that we have a polynomial function. What is the meaning of a polynomial function? A polynomial function is a function, but we have two conditions to be a polynomial. What about the first condition? Number 1, each of the domain, I mean set of x, and the codomain, I mean the set of y, or the letter y of the function is the set of real numbers. Question number 2, the power of the variables x and y, okay, the variable in x in any of its terms is what? Is a natural number. Natural number means starting with 0, 1, 2 and so on. For example, which of the following represent a polynomial function or not? Example number 1. F of x equals 4x power 3 minus 5x power 2 plus 7x minus 3. Your power 3 and 2, and you have power 1. So all your powers, what is a natural number? Okay, so your function is a polynomial or not? Yes, it's called a polynomial. Okay, what about example number 4? F of x equals x multiply 3 over x plus 9. This function is a polynomial or not? Is not a polynomial. Why? Because x, you have x in the denominator. Okay, what about this? If you have 3 over 0, so any fraction divided by 0, so it's called what? Is not a function. After that, finally, we have an example. If f of x equals x power 2 minus 3x, and we have another function g of x equals x minus 3, find f of root 2 plus 3 multiply g of root 2. Okay, example number 1. First, I will find f of root 2. So you have to substitute in the function f, okay, with the x by what? By root 2. Substitute in x equals root 2 power 2 minus 3 multiply in x root 2. So the result it will be root 2 power 2, cancel power 2 with the square root, the result it will be 2. 3 multiply root 2, 3 root 2. After that, you have to find the 3 multiply the function g, okay? يبقى 3 g of root 2, 3 multiply. Find the function g and substitute x for root 2. What about function g? X minus 3, replace x or substitute x for root 2 minus 3. After that, you have to multiply 3 by your bracket, 3 multiply root 2. It will be 3 root 2. 3 multiply negative 3, it will be 9. Again, what about the required number 1? Required number 1 said f of root 2 plus 3g root 2. So I will add 2 minus 3 root 2 plus 3 root 2 minus 9. We have 3 root 2 and its inverse negative 3 root 2, the result it will be 0. 2 minus 9 equals what? Equals negative 7. What about number 2? Prove that f of 3 equal g of 3 equals 0. Okay, I will find f of 3. So you have to substitute in your function f with x equals 3. So the result it will be 3 power 2 minus 3 multiply 3. It will be 0. What about g of 3? In your function g, you have to substitute x for 3. 3 minus 3, it will be 0. Therefore, f of 3 equals g of 3 equals 0.